In this video, I will give you an introduction to the Crust Crawler arms, and I'll show you the two ways that you can interface to them, either with a microcontroller or using your PC. The Crust Crawler arm is constructed out of 5 servos, made to look somewhat like the human arm. Imagine that my arm is hanging like this. This is the shoulder joint, this is the elbow, and this is the hand. In the shoulder joint there's 2 servos, one down here that takes care of rotation, and one here that takes care of the pitch. Here's the elbow, and in the end there's 2 servos that makes up for the gripper. Collectively you can kind of vary them a little, like the wrist. In the kit there's also an interface cable for your computer and a power supply. This is the base of our Crust Crawler arms. There's 4 boards, a power injector, an Robotics M Robocontroller, an RS-232 to RS-485 converter, and a USB to FTDI converter. The Robotics M board is an Arduino compatible controller that you can use to control the servos. The RS-232 to RS-485 converter converts the serial signals from the Robotics board to the servos that are connected through this wire here. The power injector injects 12 volts from this DC jack into this wire. As you can see on the communication wire, there's lacking 1 wire. That's the power wire. We don't want power to go back into the system this way. The USB to FTDI board is necessary because the Robotics board does not have a USB plug, so you can only program it through FTDI. You don't need to use the Robotics board to control the servos. You can use your own PC, and if you like so, you can use a converter like this that takes a USB plug in one end into your computer, converts it to RS-485, and in the other end you have a plug that goes into the power injector on the base. You simply plug it into one of the ports, and now you can communicate through the USB. You can also use this, if you're actually controlling the system with the Robotics, to snoop on whatever comes through this wire to see if you are sending some faulty messages. If you want to make sure that no communication is running here, just unplug this plug here. You might have noticed that there's an extra wire coming from this cable. That's because there's an emergency breaker on your robot. That emergency breaker lets you cut the power to the servos. So only the power is cut when you press the button. However, the communication is still on and you're not resetting the Robotics board. On some of the arms, there's a switch that lets you switch from XB to PC. This is because the XB and the PC shares the same serial connection on the Robotics, and if you want to program the Robotics, you need to switch to PC so that the XB does not interfere with the programming. You can also connect to the XBs or program them with the USB to FTDI converter, which also has an XB slot. When we first bought the arms, the Robotic M seemed like a good choice for the Robocontroller. They had interface for the RS-485, so you didn't need to care about enabling or disabling the communication, whether you wanted to read or write. And it was kind of the Robocontroller of choice for robotics. However, the software for it hasn't been updated and it doesn't work with the newer Arduino IDEs. So instead, you could simply just use a regular Arduino and then move the wires from the Robotics M over into that Arduino. So that's it. In the following videos, I will show you how to interface with the Dynamixel servos and how to actually move your arm.